Morning, students. Class, we are going to talk about file system implementation. Fourth unit. Fourth unit, we have totally three chapters are there. First one is mass storage structure, and next one is file system implementation. Okay, in previous classes, we have studied about mass storage structure and the file system interface. In this class, we are going to talk about file system implementation. This file system implementation, mainly we are going to focus on file system structure, and at the same time file system implementation and the directory implementations, and at the same time allocation methods, and finally free space management. All these things we are going to discuss in this class. See, as we know, what are the main services or main feature of the operating system is file management. See, what is meant by file management? The operating system is responsible for each and every operations related to files. It is nothing but file creation, or we can say file deletion. So here, what is this file system structure is? File system is the one of the part of the operating system which is responsible for file management. It also provides a mechanism to store the data and access the file contents, including the data and programs. See here, the major responsibility of the file system structure is to store the files as well as to access the files. And one more thing is, the file system provides efficient access to the disk by allowing data to be stored, located and retrieved in a convenient way. A file system must be able to store the files, locate the files, and at the same time retrieve the files. See here, one representation is there. Here it will shows the how the file system are divided into different layers. Here the file system structure is going to be divided into different layers, that is application programs, and at the same time logical file system, and a file organization module, and next one is basic file system, and at the same time IO control and device control. See here, when a application program asks for a file, the first request is directed to the logical file system. The logical file system contains the metadata of the file and a directory structure. If the application program does not have the required permission of the file, then this layer will throw an error. Logical file system also verify the path to the files. At the same time, generally files are divided into various logical blocks. Files are to be stored in the hard disk and to be retrieved from the hard disk. Hard disk is divided into various tracks and sectors. Therefore, in order to store and retrieve the files, the logical blocks need to be mapped into physical blocks. This mapping is done by file organization module only. It is also responsible for free space management. Once file organization module decided which physical block the application program needs, it passes this information to the basic file system. Here we have basic file system. The basic file system is responsible for issuing the commands to IO control in order to fetch those blocks. The responsibility of the IO control contains the codes by using which it can access the hard disk. These codes are known as device controls. At the same time, the IO controls are also responsible for handling the interrupts. Okay, so this is the representation of the file system structure. Next, coming to the file system implementation. So whereas coming to file system implementation, there are so many variations on disk data structures that are used to implement a file system. This structure may vary depending upon the operating system. The operating system, the Windows operating system will have different structure. At the same time, if it is Linux, it have one more structure. Whereas in this file system implementations, we are going to see about a boot control block and a volume control block and a directory structure. We can call it as a per file system and file control block. See, what is meant by boot control block? What actually this boot control block? The boot control block will contain the information which is needed for booting of an operating system. We can say boot control block contains all the information which is needed to boot an operating system from the volume. In order to boot an operating system, the information which needs this block will contain. The next one is volume control block. See, volume control block will contain the information regarding the volume, such as the number of blocks, the size of each block, and the partition table and pointer to free block and free FCB block. See, what this volume control block will contain is how many blocks, the total number of blocks, and the size of each block. Oh, this the total information about this thing will maintained by the volume control block. See, next one is directory structure. What is meant by directory structure? A directory structure contain file names and pointer to the corresponding FCBs. Okay. So what is meant by file control block? The file control block contains all the details about the file, such as ownership details and the permission details and file size. Okay. See, the who is the owner of a file, what is the permission of a file, all those informations will maintained by file control block. So this is regarding file system implementation. So next we are going to talk about a directory implementation. See, what is meant by a directory? A directory may contain several files. A collection of files, we can say it is a directory. See, in order to implement directories, we have various data structures. Among those data structures, we have mainly two algorithms are using. In order to implement a directory, here we are going to talk about majorly two algorithms. Those two are linear list and the second one is hash table. Okay. So what is meant by linear list? What is meant by hash table? See, here there are number of algorithms by using which the directories can be implemented. However, the selection of an appropriate directory implementation algorithm may significantly affect the performance of the system. Okay. The directory implementation algorithm classified according to data structures they are using. Okay. At the same time, the mainly two data structures are linear list and the second one is hash table. See, in this linear list, in this algorithm, all the files in a directory are maintained as a single linked list. As we know, what is a single linked list? So, single linked list is nothing but it is a collection of nodes which are connected by a single link. Okay, a node contains two ports, data port and address port. So in this way, if we have two elements in a single linked list, one element in one node and the second element in second node, these two nodes are connected by a single link. Of course, data port will have data and the address port will have next address of the next node. Okay, so in this way we are going to store the files. If you see the here representation, here we have two files, file name 1 and file name 2. Okay, file name 1 and file name 2. These two files are connected by a single link. It is just like as a single linked list only. Here each file contains the pointer to the block which are assigned to the next file. Here file name 1 will have one link which is pointing to the file name 2. Okay. Here again file name 2 will have one link which that is pointing to the file name 3, that is next node. Okay. So what are the main characteristics of the linear list? When a new file is created, then the entire list is checked whether the new file name is matching to a existing file name or not. So generally, if you take directory, we can't keep two same file names in a directory. So here what will happen is, if you are creating one file, see for that creation, first we have to check whether that file name is already there or not. If it is not there only, we are going to create that file name. Why? Because we can't keep two file names in a same directory. At the same time, the file can be created at the beginning or end. Okay, the creation of the file may be a beginning or end, but whatever the file we are creating, that file name should not contain in a directory. So for that one, we have to perform the operation of traverse. Therefore, searching for a unique name is a big concern here, because traversing will take more time. See here, what I'm saying is, if you want to create one file, for example, DBS is one file. If you want to create that file, first of all, we have to check whether that file is already present in the directory or not. Okay, in order to check, what we have to do, we have to perform the traverse operation. Okay, we have 10 files is there. So we have to check what is the file name of first file, what is the file name of second file, third file, like that. If it is not, if its DBS file name is not there now, then only we have to create the that file name. If its DBS file is there, then we can't create the DBS file in the same directory. So this is one of the drawback. The major drawback is traversing. That means searching process will take more time. Why? Because it is linear. Linear means we have to, linear we can say sequential. We have to search linearly. And the next one is the list need to be traversed in case of every operation. See here, what will happen is if we want to perform creation, or if we want to create, or if we want to perform deletion, or if we want to perform updation, for each and every operation, definitely we are going to perform the one operation called as searching, okay, or we can say traversing. So this is one of the one more drawback in the linear list. In order to avoid the drawbacks in here, the major drawback is traversing or searching. So for example, if we want to delete one file, for deletion, what we have to do? Definitely, again, we have to perform the search operation. Why? Because we don't know which file we are deleting. So in order to delete, again, we are going to perform the search operation. Okay, so here major drawback is performing the search operation, or we can say traversing. So in order to avoid the drawbacks in linear list, we are going to use the hash table. To overcome the drawbacks of single linked list implementation of directories, there is an alternative approach that has hash table. Okay, this approach suggests to the hash table along with the linked list. Here we have linked list along with hash table. See, if you see the representation, in this hash table, we have key along with value. We have key along with value. So in order to know the address of a particular value, we are going to use the hash function. We know how we are going to implement the hash function. As already we have said, we have studied in the data structure, h of k equal to k mod n. Okay, why we are using hash function? In order to get the accurate address in a particular hash table, then we are going to use the hash function. To know the particular address, directly we are to know the address of a particular row, definitely we are going to use the hash table, hash function for the hash table. Here a key pair for each file in the directory gets generated and stored in the hash table. The key can be determined by applying the hash function on the file name, while the key points to the corresponding file stored in the directory. Okay, here whatever the files we have, that files that should be in hash table itself. Okay, in previous case we are not using hash table, but in this case, along with single linked list, we are maintaining the hash table. Okay, whatever the information present in the file, that total file information will be in hash table only. Okay, well, here mainly we are going to reduce the searching time. Okay, see, for example, in this case, if we want to create one file, no need to go and search all the files. Simply by seeing the hash table, we are going to know whether that file is present in the directory or not. Now the searching become efficient due to the fact that now entire list will not be searched on every operation. Only hash table entries are checked using the key, and if an entry found, then the corresponding file will be fetched using the value. Okay, so these two are the major implementation techniques of a directory. Okay, first one is linear and the second one is hash function. So next one is majorly we are going to talk about the allocation methods. See, what is meant by allocation methods? Okay, if you have data, how the data will be allocated in a block. So we can say it is a secondary disk or a hard disk. There are various methods which can be used to allocate disk space to the files. If I have a file, if I want to store, if I want to allocate the file in a disk, there are various methods are there. Among those one, we have majorly three methods are there. First one is continuous allocation, linked allocation, and as well as indexed allocation. Selection of an appropriate allocation method will be significantly affect the performance. Okay. So if you select one best method, best allocation, automatically it will impact on the performance also, and the efficiency of the system also it will impact. Allocation method provides a way in which the disk will be utilized and the files to be accessed. Whereas among this one, first one is continuous. See how this continuous allocation will be done. See, continuous means we can say contiguous, or we can say continuous, or we can say sequence. Okay. See, continuous means we can say it is a sequence. If the blocks are allocated to the file in such a way that all the logical blocks of the file get the continuous physical blocks in the hard disk, then such allocation scheme is known as continuous. Okay, if we have some blocks and we have file, a file may allocated in a continuous blocks, then we can say it is simply continuous allocation. See here in this example of continuous allocation block, if you see here, there are two examples are there. Two examples are showing different file names with allocations. See here, file name is abc.txt. Here next one is video.mp3 and next one is jpg.document. Here, see here we have the hard disk. Hard disk is divided into number of blocks. Hard disk is divided into number of blocks. Here three files are there. That is ABC, video, JPG. Here I am giving the starting block and ending block. Starting block and at the same time not ending block. It is the length of the block. Length of the block. Okay. See for example here this hard disk is divided into number of blocks. That is 0 to 11. 0 to 11. 0, 1, 2 like this up to 11. See here what will happen. File name ABC. The file name ABC. The starting block is 0. The starting block is 0. The length of the block is 3. It means it will continuously occupies the blocks or continuous occupation of the blocks are 0, 1, 2. Why? Because the length of the file name is 3. So continuously it will allocate 3 blocks. That is from 0 to 2. That is 0, 1, 2. Okay. What is the length? 3. So here it will allocate continuously 3 blocks, that is 0, 1, 2. Okay, like this. Next one is video. It is one file name. So okay, the starting block size block address block is given, that is 4. From 4 fourth block onwards it should allocated. What is the length of the this file name? Video 2. That means 2 means 4 and 5. Okay, like this JPG. This is one file name. See starting one is 9. From 9 to what is the length? 3. 3 means 9, 10, 11. That means continuous. Continuous blocks it should be allocated. So the same example only here the file names are different. Count like no next one is TR, next one is mail, list, F. These are the file names. Here we have given starting and the length. Okay. Starting for the count file. What is the starting? 0. What is the length? 2. It means 0, 1. Okay, next file is TR. TR, what is the starting block? 14. From 14 to what is the length? 3. That means 14, 15, 16. See here 14, 15, 16. Okay, if you see the representation, we have some darted area. Okay, so 14, 15, 16 like that. Again, mail. Mail means 19. From starting with 19. 19 to 6. That means 19, 20, 21, 22, 23, 24. Okay, like that. That means it will give it here file name will give the starting and the length. Okay, it will start from the starting location and length means continuous block. So this is the continuous allocation. Here the simple thing is in continuous allocation all the blocks are allocated in a continuous manner. Okay. So next one is linked list allocation. Okay, next one is linked list allocation. So what are the one more thing is the advantages of the continuous allocation. It is simple to implement. At the same time, we will get excellent read performance in the continuous. At the same time, it supports a random access into files, whereas it has some drawbacks also. So whereas coming to drawbacks, it may be difficult to have a file grow. Okay, it may be difficult to have file grow means, for example, if the size of the file may increases, we can't store that particular file name. Okay. So at the same time, one more drawback is the disk will become fragmented. Okay, these are the drawbacks. Next, coming to linked list allocation. In this linked list allocation, solve all the problems in continuous allocation. Whereas in this linked list allocation, what will happen is each file is considered as the linked list of disk block. However, the disk blocks allocated to a particular file need not to be a continuous on the disk. Here there is no continuous. Each block, disk block allocated to a file containing a pointer which points to the next disk block allocated to the same file. Here what will happen is, if you see the representation, here we have directory file name A. This is the starting address, starting block number, that is star 9, and the ending block is 13. Okay, so here starting block will point to the starting start will block to the starting block, and next one is 13. 13 is the end block. Okay, So again 13 will pointing to the end block. Okay, see if you see the representation now. So in this bit, in this middle, we have to store any blocks. There is no continuous representation. Okay, so if you see this one file name A, first starting block is 9, from 9 to 4, from 4 to 1, 1 to 6, 6 to 11, and 11 to 13. Okay, here in this directory we are going to mention the starting block and ending block. In this between 9 to 13, this is the starting, this is the 13. Starting is 9, ending is 13. In this middle, we have to allocate any manner. That means any block may be allocated. There is no continuous. In previous class, there is continuous. Here, after 9, which block we are going to allocate? 4. There is no continuous. After 4, we have again 1. After 1, we have 6. After 6, we have 4. Like that. Okay. Totally, how many? What is the size? 1, 2, 3, 4. Okay. Over now. So like this, there is no continuous block allocation here. At the same time, here also same example only. Here file name is there. Starting is 9, ending is 25. Here starting is 9. Okay. Ending is 25. In this between 9 to 25, the allocation may be a different. There is no continuous allocation. Okay. So here we are given only starting block and ending block linked list. So in this one also we have advantages as well as disadvantages. The advantages are there is no external fragmentation with linked list. Any free block can utilize it in order to satisfy the file block request. File can continue to grow as long as the free blocks are available. Whereas coming to disadvantages, in these disadvantages, random access is not provided. Random access means we want to access particular block, we can't access. As well as pointers require some space in the hard disk block. Definitely, it will use the concept of pointers. Definitely, pointers will take more memory. And next one is need to be traversed each block. Definitely, we are going to in this method we are going to perform the traverse of each block. This is one of the drawback of linked list allocation. Whereas in this next one is indexed allocation scheme. Okay, indexed allocation scheme, what will happen is instead of maintaining file allocation table of all disk pointers, index allocation scheme store all the disk pointer in one of the block called as disk block. Okay, so this is the disk block. Okay, in this disk block, what will contain? It will store all the disk pointers in one of the block. Okay, these are all the disk blocks. Okay, so 11 is the main block. From 11 to again 3, 6, 10, 13, 15 like that. Okay, so this is representation. So these two representations are same only. Here this is also disk block. Okay, in this disk block we have various blocks. In which blocks it is going to, that particular file name is going to be allocated. Indexed block don't hold all the file data, but it holds the pointers to all the disk blocks as located to that particular file. Directory entry will only contain the index block address. Okay. Here the simple thing is in this indexed allocation scheme, what will happen is we have only one block. That block we will call as index block. In this indexed block, we have the various allocation blocks. Okay. See, if you see here, index block is 11. So this is 11. So in this blocks, what we are having is that particular, what is the blocks of a particular file? What is the blocks of a particular file? See here, indexed blocks are 11. So what are the various blocks is 6 to 3, 10, like 13, 14, 16 like that. So from 11 to we have 3. From 11 to 6, 11 to 10, 11 to 13, 11 to 14, 11 to 15 like that. Okay. So this is the index allocation scheme. Whereas coming to what are the various advantages and disadvantages of indexed one is, advantages are it supports direct access. Why? Because we can directly access. Here we have block, indexed block now. So by using that one, we are going to directly access the particular block. And next one is a bad data block causes the loss of only that block. At the same time, disadvantages are a size of a file depends upon the number of pointers, and index block can hold. Next, at the same time, it is having index block for a small file, totally wastage. So these are the drawbacks. Next, coming to the free space management. See, what is meant by free space management. Okay, here in this free space management, in order to implement this free space management, we have again two techniques are there: bit vector and linked list. Here, free space management is nothing but which blocks are free, which blocks are allocated. Okay, in a hard disk is divided into number of blocks. So by seeing this free space management, which blocks is allocated, which blocks are free. We are going to know how many blocks are allocated, how many blocks are free. A file system is responsible to allocate the free blocks to the file. Therefore, it has to keep track of all the free blocks present in the disk. There are many approaches for implementing this free space management. Among those, major ones are bit vector and next one is linked list. See, what is meant by bit vector? In this bit vector, in this approach, the free space list is implemented as a bitmap vector. It contains the numbers of bits where each bit represents each block. Here, each bit means each block. A bit represents one block. In the block, if the block is empty, then bit is 1, otherwise 0. Okay, here you should note this point. If the block is empty, then bit value is 1. Okay, if block is contains some data, the value is 0. If a block may contain data, it will represent it by 0. If block does not have data, that means a block is empty, then the value of that block is 1. Here we are going to use two values, 0 and 1. If it is data, 0. If it is empty, then representation is 1. Initially, all the blocks are empty. Therefore, each bit in the bitmap vector contains 1. Why? Because initially we don't have any data. So initially all the bits are in the bitmap vector is 1. Why? Because all are empty. If it is data, then we are going to represent 0. If it is 1, there is no data like this. See, for example, here, consider a disk where each block, that is block numbers we have given now, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 17, 18, 26, 25, 25, 26, 27 are free. All these are free and the rest of the blocks are allocated. Okay, rest of the blocks are allocated. How we are going to represent this one by using the bit vector? Okay, here 2, 3, 4, 5. These bits are free. Okay, what is meant by free? Free is nothing but empty. Empty means which bit you are going to represent? 1. Okay, so if it is dead, that means 2 means 0, 1. These two bits are, we have data. So in order to represent the data, we are going to use the bit is 0. So here 0, 0, 2 zeros is there. Why? Because 0, 1. These two zeros represent 0, 1. These two we have data. Again in here 2, 3, 4, 5 continuous 2, 3, 4, 5. These blocks are free. What is meant by free? Free is nothing but empty. Empty is nothing but 1. In order to represent the free, we are going to use the value 1. So continuous 4 ones. 1, 1, 1, 1. It means 2, 3, 4, 5. Okay. Again after 5, 8 is free means 6, 7 are already allocated. 6 to 7 is allocated. So in order to represent 6 to 7, again 2 zeros. 6 to 7, 2 zeros we are using. Why? Because the block number 6, block number 7 is allocated. In order to represent the allocation of a particular block, we are going to use the bit value 0. Okay, again 2 zeros. Next one is continuous 8, 9, 10, 11, 12, 13. Okay, continuous, these blocks are free. So free means 1. Okay, so for 8, 9, 10, 11, 12, 13. All are ones. Again, after 13, 14, 15, 16. Okay, 14, 15, 16. These three are not there here. Not there means it is data is there. Okay, here we are representing only free blocks. Okay, if data is there now. So data is there means the value is 0. Like this, we are going to represent by using the bit vector. Next one is linked list. How we are going to implement free space management by using linked list. In this linked list, an approach to free space management is to link together all the free disk blocks, keeping a pointer to the first free block in a special location on the disk and catching in it a memory. The first block contains a pointer to the next free block and so on. Okay, here what will happen is we are going to use the linked list manner. The first block contains a pointer to the next free disk block and so on. Recall our same example. Okay, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 17, 18, 25, 26, and 27. These are free, and the rest of the blocks are allocated. Just now we have seen in bit vector. In this situation, we should keep a pointer to block number 2. Okay, this is the initial block number as a first block, and the block number 2 would contain a pointer to block number 3. Again, block number 3 will have pointer to block number 4. 4 from block number 4 to 5, block number 5 to 8, 8 to 9, 9 to 10, like this. Okay, only the blocks which have data, that blocks only we are going to represent. Remaining blocks are all are vacated. Okay, remaining blocks all are vacated by using this linked list implementation. So here, block number 2, block number 3, block number 4, 5, 8, 9, 10, 11, 12, 13, all these blocks are free, and the rest of the blocks we have allocation. Okay, so we are going to keep these blocks as linked list manner. Remaining blocks are allocated. That means if you see this hard disk blocks, only we are going to represent only these blocks are the particular blocks are free. Only particular blocks are free. That is 2, 3, free. Okay. Remaining blocks, that means 0, 1. 0, 1 is 0 block, 1 block is allocated. Okay. So if you see the here representation, that is here a dark area, block number 2, block number 3, block number 4, block number 5. Okay, dark area. That means the dark region is there. So that is free. The remaining block. Okay, we have in box white some light color. Okay, here 0, 1. 0, 1 means it is allocated. Again, the simple thing is in this linked list method, what will happen is the free blocks are linked in a fashion. That means block 2 will have first free block. From block 2 will contain the pointer to block 3. Block 3 will contain the pointer to block 4. Block 4 will contain the pointer to block 5. Block 5 will contain the pointer to block 8. Block 8 will contain the pointer to the block 9, like that. Okay, in this manner, we are going to represent the free blocks and as well as allocated blocks. Okay, so this is regarding free space management. Okay.